Now, converting equations is a lot less straightforward than converting points. For your reference, I have included all of our most important equations that we talked about in the last video up at the top. X equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, and tangent of theta equals y over x. So we're going to start by converting rectangular or Cartesian equations into polar equations. So we're going to convert x and y into r and theta. So what I would do first on this problem is simplify it out. So we have x minus 3 squared. Let's actually square that and distribute, FOIL it all out. So we get x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is another negative 3x, which gives me negative 6x. And negative 3 times negative 3 is a positive 9. Now the next thing I would notice that if I bring the 9 over, they're both going to cancel out. So I have x squared, and I'm going to bring the y squared up, and you'll see why in just a second. This is what I've got so far. Now the reason I brought the y up is because that matches one of our equations. X squared plus y squared is r squared. And I can change x to r cosine of theta. Once again, from those equations at the top of your paper. So I do have things in terms of r and theta now, but I can also simplify this more. Because they both have an r in common, let's take that r out. And now that they took the r out, I can set them individually equal to 0. And I want you to note really quickly, r equals 0 is not actually a graph, an equation, it's a point. What does it look like if the radius equals 0? Well, if the radius of the circle equals 0, that's just a point at the origin. So because this is just a point at the origin, we're just going to ignore the r equals 0 part and just instead focus on this next part. So I have r minus 6 cosine of theta equals 0. Let's solve this for r. So I get r equals 6 cosine of theta. And that is my answer. I have converted it from an equation with x's and y's to an equation with r's and thetas. And I solved for r. That is an important part, making sure you solve for r or solve for theta. And I wanted to take you to Desmos real quick to show you that these two equations are actually the same graph. So I took this equation first into Desmos, and this is the graph it gave me. Over here, x minus 3 squared plus y squared equals 9. Now I can take my second equation, r equals 6 cosine of theta, and notice if I turn that one on, it is the exact same graph. So these are the same equations. One just uses x's and y's. The other uses r's and thetas. So let's try our next one. Here we have y equals negative x. Don't have any squareds to turn into r squareds here. So I'm just going to start by changing y into r sine of theta and x into negative r cosine of theta. Let's bring everything to one side, because I'll notice when I bring everything to one side, they have an r in common that I can factor out. So take that r out. And once again, once you take it out, you can set them individually equal to 0. And r equals 0, same as the last problem, is just a point, so I can ignore that. And come over here to get sine of theta plus cosine of theta equals 0. Let's bring that cosine of theta to the other side and think about this problem a little bit. So if we think about this as the unit circle, we know that sine of theta is our y value, and cosine of theta is our x value for unit circle. So think, where on the unit circle does the y value equal the negative of the x value. So think of our unit circle. First off, where does the y value equal the x value? Where are the y value and the x value of your point the same? That happens at our fourths. Those are the places where the x value and the y value are the same. Now, we want the y value to be the opposite sign of the x value. So that only happens at 3 pi fourths and negative pi fourths. Or we would say 3 pi fourths plus pi k. This is the place, these are the angles where this happens, where the sine value equals the negative of the cosine value. So, since they're angles, I could write this as theta equals 3 pi fourths. And if you think about this, we know that the graph of y equals negative x looks like this. That is that line. That is y equals negative x. So theta equals 3 pi fourths. You're taking all the radiuses that we want along the line of 3 pi fourths. So basically we're taking all the points r, comma, 3 pi fourths, where r can be any number, but theta will always be 3 pi fourths. So if r is positive, that gives us this part of the graph. And then if r is negative, that takes us across the circle to give us this part of the graph. So at the end of the day, theta equals 3 pi fourths is the same thing as the y equals negative x line. Let's try one more where we're converting Cartesian or rectangular equations into polar equations. Let's start once again. We don't have an x squared and a y squared, so we're not going to get an r squared out of this. So let's just change y to r sine of theta and x to r cosine of theta. Now remember, when I square this, I have to square both of these. So I get r sine of theta equals r squared cosine squared of theta. Let's bring everything to one side and see what we can take out. We get r sine of theta minus r squared cosine squared of theta equals 0. I notice once again they have an r in common, so I'm going to take that r out. And split it up. I get r equals 0, sine of theta minus r cosine. Oops, this should be still squared. Get rid of the r equals 0 because we know that's just a point. And now that I've got this, I'm going to solve it for r. So let's minus sine of theta. So I get negative r cosine squared of theta equals negative sine of theta. Divide by negative cosine squared of theta. So I get r equals sine of theta over cosine squared of theta. Or we could use our identities to change this to sine of theta over cosine theta times 1 over cosine theta. Notice that if I multiply those two together, I get the exact same thing. So I'm just splitting them up, because then sine over cosine is tangent and 1 over cosine is secant. And we can actually check this one in Desmos. If I take this equation and put them in Desmos, as you can see right here. So right now I just have y equals x squared. There's my parabola. Then I also have my r equals tangent theta secant theta. If I turn that one on, notice they are the exact same graph. So they're the same equation. One is just written with y's and x's. The other is written with r's and thetas. So that is it for this video, where we turn x and y equations into r and theta equations. In the next video, we'll go the other direction. That'll be the last video for this lesson. we'll change r and theta equations into x and y equations.